A measuring instrument is a device for measuring a physical quantity. In the physical sciences, quality assurance, and engineering, measurement is the activity of obtaining and comparing physical quantities of real-world objects and events. Established standard objects and events are used as units, and the process of measurement gives a number relating the item under study and the referenced unit of measurement. Measuring instruments, and formal test methods which define the instrument's use, are the means by which these relations of numbers are obtained. All measuring instruments are subject to varying degrees of instrument error and measurement uncertainty. Scientists, engineers and other humans use a vast range of instruments to perform their measurements. These instruments may range from simple objects such as rulers and stopwatches to electron microscopes and particle accelerators. Virtual instrumentation is widely used in the development of modern measuring instruments. Time. In the past, a common time measuring instrument was the sundial. Today, the usual measuring instruments for time are clocks and watches. For highly accurate measurement of time, an atomic clock is used. Energy. Energy is measured by an energy meter. Examples of energy meters include electricity meter. An electricity meter measures energy directly in kilowatt-hours. Gas meter. A gas meter measures energy indirectly by recording the volume of gas used. This figure can then be converted to a measure of energy by multiplying it by the calorific value of the gas. Power. A physical system that exchanges energy may be described by the amount of energy exchanged per time interval, also called power or flux of energy. See any measurement device for power below. For the ranges of power values see orders of magnitude. Action. Action describes energy summed up over the time a process lasts. Its dimension is the same as that of an angular momentum. A photometer provides a voltage measurement which permits the calculation of the quantized action of light. Also see photoelectric effect. Mechanics. This includes basic quantities found in classical and continuum mechanics, but strives to exclude temperature-related questions or quantities. Length, distance, or range meter. For the ranges of length values see orders of magnitude. Area, planimeter. For the ranges of area values see orders of magnitude. Volume. Buoyant weight, overflow trough, measuring cup, flow measurement devices, graduated cylinder, pipette, eudiometer, pneumatic trough. If the mass density of a solid is known, weighing allows to calculate the volume. For the ranges of volume values see orders of magnitude, mass or volume flow measurement, gas meter, mass flow meter, metering pump, water meter, speed, airspeed indicator, radar gun, a Doppler radar device, using the Doppler effect for indirect measurement of velocity. Speedometer, tachometer, tachymeter, variometer. For the ranges of speed values see orders of magnitude, acceleration, accelerometer, mass. Balance, automatic checkweighing machines, catharometer, weighing scales, inertial balance. Mass spectrometers measure the mass-to-charge ratio, not the mass. For the ranges of mass values see orders of magnitude, linear momentum, ballistic pendulum, force gauge, spring scale, strain gauge, torsion balance, tribometer. Pressure, anemometer, barometer used to measure the atmospheric pressure. Manometer see pressure measurement, pitot tube, tire pressure gauge in industry and mobility. For the ranges of pressure values see orders of magnitude. Angle, circumferenter, cross-staff, goniometer, graphometer, protractor, quadrant, reflecting instruments, octant, reflecting circles, sextant. Theodolite, angular velocity or rotations per time unit, stroboscope, tachometer. For the value ranges of angular velocity see orders of magnitude. For the ranges of frequency see orders of magnitude. Torque, dynamometer, Taproni brake, torque wrench, orientation in three-dimensional space. See also the section about navigation below. Level, dumpy level, laser line level, spirit level, direction, gyroscope, energy carried by mechanical quantities, mechanical work, ballistic pendulum, indirectly by calculation and or gauging, electricity, electronics and electrical engineering. Considerations related to electric charge dominate electricity and electronics. Electrical charges interact via a field. That field is called electric if the charge doesn't move. If the charge moves, thus realizing an electric current, especially in an electrically neutral conductor, that field is called magnetic. Electricity can be given a quality a potential. And electricity has a substance-like property, the electric charge. Energy in elementary electrodynamics is calculated by multiplying the potential by the amount of charge found at that potential, potential times charge. Electric charge, electrometer is often used to reconfirm the phenomenon of contact electricity leading to triboelectric sequences. Torsion balance used by Coulomb to establish a relation between charges and force, see above. For the ranges of charge values see, orders of magnitude, electric current, ammeter, clamp meter, galvanometer, D'Arsonval galvanometer, voltage, oscilloscope allows to quantify time-dependent voltages, voltmeter, electric resistance, electrical conductance, ohmmeter, time-domain reflectometer characterizes and locates faults in metallic cables by runtime measurements of electric signals. Wheatstone bridge, electric capacitance, capacitance meter, electric inductance, inductance meter, energy carried by electricity or electric energy meter, electricity meter, power carried by electricity, wattmeter. These are instruments used for measuring electrical properties. Also see meter. Electric field, field mill, magnetic field. See also the relevant section in the article about the magnetic field. Compass, Hall effect sensor, magnetometer, proton magnetometer, squid. For the ranges of magnetic field see, orders of magnitude, combination instruments, multimeter, combines the functions of ammeter, voltmeter and ohmmeter as a minimum. LCR meter, combines the functions of ohmmeter, capacitance meter and inductance meter. Also called component bridge due to the bridge circuit method of measurement. Thermodynamics, temperature-related considerations dominate thermodynamics. There are two distinct thermal properties, a thermal potential the temperature. For example, a glowing coal has a different thermal quality than a non-glowing one. And a substance-like property, the entropy. For example, one glowing coal won't heat a pot of water, but 100 will. Energy in thermodynamics is calculated by multiplying the thermal potential by the amount of entropy found at that potential, temperature times entropy. Entropy can be created by friction but not annihilated. Amount of substance, a physical quantity introduced in chemistry. Usually determined indirectly. If mass and substance type of the sample are known, then atomic or molecular masses give direct access to the value of the amount of substance. See also the article about molar masses. If specific molar values are given, then the amount of substance of a given sample may be determined by measuring volume, mass or concentration. See also the subsection below about the measurement of the boiling point. Gas collecting tube gases, temperature, electromagnetic spectroscopy, Galileo thermometer, gas thermometer principle, relation between temperature and volume or pressure of a gas. Constant pressure gas thermometer, constant volume gas thermometer. Liquid crystal thermometer, liquid thermometer principle, relation between temperature and volume of a liquid. Alcohol thermometer, mercury and glass thermometer. Pyrometer principle, solar radiation flux density relates to surface temperature. Pyrometer's principle, temperature dependence of spectral intensity of light, that is the color of the light relates to the temperature of its source, range, from about 50 degrees Celsius to plus 4000 degrees Celsius. Note, measurement of thermal radiation means, no physical contact becomes necessary in temperature measurement. Also note, thermal space resolution found in thermography. Resistance thermometer principle, relation between temperature and electrical resistance of metals, range, 10 to 1000 kelvins, application in physics and industry, solid thermometer principle, relation between temperature and length of a solid. Bimetallic strip. Thermistor's principle, relation between temperature and electrical resistance of ceramics or polymers, range from about 0.01 to 2000 kelvins. Thermocouple's principle, relation between temperature and voltage of metal junctions, range from about 200 degrees Celsius to plus 1350 degrees Celsius. Thermometer. Thermocouple is a set of connected thermocouples, triple-point cell used for calibrating thermometers. Imaging technology. Thermographic camera uses a microbolometer for detection of heat radiation. See also temperature measurement and category, thermometers. More technically related may be seen thermal analysis methods in materials science. For the ranges of temperature values see, orders of magnitude, energy carried by entropy or thermal energy. This includes thermal capacitance or temperature coefficient of energy, reaction energy, heat flow. Calorimeters are called passive if gauged to measure emerging energy carried by entropy, for example from chemical reactions. Calorimeters are called active or heated if they heat the sample, or reformulated, if they are gauged to fill the sample with a defined amount of entropy. Actinometer measures the heating power of radiation. Constant temperature calorimeter, phase change calorimeter, for example an ice calorimeter or any other calorimeter observing a phase change or using a gauged phase change for heat measurement. Constant volume calorimeter, also called bomb calorimeter, constant pressure calorimeter, enthalpy meter or coffee cup calorimeter, differential scanning calorimeter, reaction calorimeter. See also calorimeter or calorimetry. Entropy. Entropy is accessible indirectly by measurement of energy and temperature. Entropy transfer. Phase change calorimeters energy value divided by absolute temperature give the entropy exchanged. Phase changes produce no entropy and therefore offer themselves as an entropy measurement concept. Thus entropy values occur indirectly by processing energy measurements at defined temperatures, without producing entropy. Constant temperature calorimeter, phase change calorimeter, heat flux sensor uses thermopiles which are connected thermocouples to determine current density or flux of entropy. Entropy content, the given sample is cooled down to absolute zero. At absolute zero temperature any sample is assumed to contain no entropy. Then the following two active calorimeter types can be used to fill the sample with entropy until the desired temperature has been reached. Constant pressure calorimeter, enthalpy meter, active, constant temperature calorimeter, phase change calorimeter, active, entropy production, processes transferring energy from a non-thermal carrier to heat as a carrier do produce entropy. Either the produced entropy or heat are measured or the transferred energy of the non-thermal carrier may be measured. Calorimeter, any device for measuring the work which will or would eventually be converted to heat and the ambient temperature, entropy lowering its temperature without losing energy produces entropy. Calorimeter, temperature coefficient of energy or heat capacity, concerning a given sample, a proportionality factor relating temperature change and energy carried by heat. If the sample is a gas, then this coefficient depends significantly on being measured at constant volume or at constant pressure. Constant volume calorimeter, bomb calorimeter, constant pressure calorimeter, enthalpy meter, specific temperature coefficient of energy or specific heat, the temperature coefficient of energy divided by a substance-like quantity describing the sample. Usually calculated from measurements by a division or could be measured directly using a unit amount of that sample. For the ranges of specific heat capacities see, orders of magnitude, coefficient of thermal expansion, dilatometer, strain gauge, melting temperature, thiol tube, Koffler bench, differential scanning calorimeter gives melting point and enthalpy of fusion. Boiling temperature, ebullioscope, a device for measuring the boiling point of a liquid. This device is also part of a method that uses the effect of boiling point elevation for calculating the molecular mass of a solvent. See also thermal analysis, heat. More on continuum mechanics, this includes mostly instruments which measure macroscopic properties of matter, in the fields of solid-state physics. In condensed matter physics which considers solids, liquids and in-betweens exhibiting for example viscoelastic behavior. Furthermore fluid mechanics, where liquids, gases, plasmas and in-betweens like supercritical fluids are studied. Density, This refers to particle density of fluids and compact, solids like crystals, in contrast to bulk density of grainy or porous solids. Aerometer liquids, dosimeter gases, gas-collecting tube gases, hydrometer liquids, pycnometer liquids, resonant frequency and damping analyzer solids. For the ranges of density values see, orders of magnitude, hardness of a solid, durometer, shape and surface of a solid, holographic interferometer, laser-produced speckle pattern analyzed, resonant frequency and damping analyzer, trubometer, deformation of condensed matter, strain gauge or below, elasticity of a solid, resonant frequency and damping analyzer. Using the impulse excitation technique, a small mechanical impulse causes the sample to vibrate. The vibration depends on elastic properties, density, geometry and inner structures. Plasticity of a solid, cam plastometer, plastometer. Tensile strength, ductility or malleability of a solid, universal testing machine, granularity of a solid or of a suspension, grindometer, viscosity of a fluid, rheometer, viscometer, optical activity, polarimeter, surface tension of liquids, tensiometer, imaging technology, tomograph, device and method for non-destructive analysis of multiple measurements done on a geometric object, for producing 2- or 3-dimensional images, representing the inner structure of that geometric object. Wind tunnel. This section and the following sections include instruments from the wide field of category, materials science, materials science. More on electric properties of condensed matter, gas. Permittivity, relative static permittivity, or electric susceptibility, capacitor. Such measurements also allow to access values of molecular dipoles. Magnetic susceptibility or magnetization, Gauss balance. For other methods see the section in the article about magnetic susceptibility. See also the category, electric and magnetic fields in matter, substance potential or chemical potential or molar Gibbs energy, phase conversions like changes of aggregate state, chemical reactions or nuclear reactions transmuting substances, from reactants to products, or diffusion through membranes have an overall energy balance. Especially at constant pressure and constant temperature, molar energy balances define the notion of a substance potential or chemical potential or molar Gibbs energy, which gives the energetic information about whether the process is possible or not, in a closed system. Energy balances that include entropy consist of 2 parts, a balance that accounts for the changed entropy content of the substances, and another one that accounts for the energy freed or taken by that reaction itself, the Gibbs energy change. The sum of reaction energy and energy associated to the change of entropy content is also called enthalpy. Often the whole enthalpy is carried by entropy and thus measurable calorimetrically. For standard conditions in chemical reactions, either molar entropy content and molar Gibbs energy with respect to some chosen 0 point are tabulated, or molar entropy content and molar enthalpy with respect to some chosen 0 are tabulated. The substance potential of a redox reaction is usually determined electrochemically current-free using reversible cells. Redox electrode. Other values may be determined indirectly by calorimetry. Also by analyzing phase diagrams. See also the article on electrochemistry. Submicrostructural properties of condensed matter, gas, infrared spectroscopy, neutron detector, radio frequency spectrometers for nuclear magnetic resonance and for electron paramagnetic resonance, Raman spectroscopy, crystal structure, an X-ray tube, a sample scattering the X-rays and a photographic plate to detect them. This constellation forms the scattering instrument used by X-ray crystallography for investigating crystal structures of samples. Amorphous solids lack a distinct pattern and are identifiable thereby. Imaging technology, microscope, electron microscope, transmission electron microscope. Optical microscope uses reflectiveness or refractiveness of light to produce an image. Scanning acoustic microscope, scanning probe microscope, atomic force microscope, scanning electron microscope, scanning tunneling microscope. Focus variation, X-ray microscope. See also the article on spectroscopy and the list of materials analysis methods. Rays, sound, compression waves in matter, microphones in general. Sometimes their sensitivity is increased by the reflection and concentration principle realized in acoustic mirrors. Laser microphone, seismometer, sound pressure, microphone or hydrophone properly gauged, shock tube, sound level meter. Light and radiation without a rest mass, non-ionizing, antenna, bolometer measuring the energy of incident electromagnetic radiation, camera, EMF meter, interferometer used in the wide field of interferometry, optical power meter, microwave power meter, photographic plate, photomultiplier, phototube, radio telescope, spectrometer, T-ray detectors. For lux meter, see the section about human senses and human body. See also category, optical devices, photon polarization, polarizer, pressure, Nichols radiometer, radiant flux, the measure of the total power of light emitted. Integrating sphere for measuring the total radiant flux of a light source. Radiation with a rest mass, particle radiation, cathode ray, Crookes tube, cathode ray tube, a phosphor-coated anode, atom polarization and electron polarization, Sturmy-Gerlach experiment. Ionizing radiation. Ionizing radiation includes rays of particles as well as rays of waves. Especially X-rays and gamma rays transfer enough energy in non-thermal, collision processes to separate electron, S, from an atom. Particle and ray flux, bubble chamber, cloud chamber, dosimeter, a technical device realizes different working principles. Geiger counter, microchannel plate detector, photographic plate, photostimulable phosphors, scintillation counter, Lucas cell, semiconductor detector, proportional counter, ionization chamber, identification and content. This could include chemical substances, rays of any kind, elementary particles, quasi-particles. Many measurement devices outside this section may be used or at least become part of an identification process. For identification and content concerning chemical substances, see also analytical chemistry, especially its list of chemical analysis methods and the list of materials analysis methods. Substance content in mixtures, substance identification, carbon dioxide sensor, chromatographic device, gas chromatograph separates mixtures of substances. Different velocities of the substance types accomplish the separation. Calorimeter, gas detector in combination with mass spectrometer. Mass spectrometer identifies the chemical composition of a sample on the basis of the mass-to-charge ratio of charged particles. Nephelometer or turbodiameter, oxygen sensor, refractometer, indirectly by determining the refractive index of a substance. Smoke detector, ultracentrifuge, separates mixtures of substances. In a force field of a centrifuge, substances of different densities separate. pH, concentration of protons in a solution, pH meter, saturated colomol electrode, humidity, hygrometer measures the density of water in air, lysiometer measures the balance of water in soil, human senses and human body. Sight, brightness, photometry. Photometry is the measurement of light in terms of its perceived brightness to the human eye. Photometric quantities derive from analogous radiometric quantities by weighting the contribution of each wavelength by a luminosity function that models the eye's spectral sensitivity. For the ranges of possible values, see the orders of magnitude in illuminance, luminance, and luminous flux. Photometers of various kinds, lux meter for measuring illuminance, that is incident luminous flux per unit area, luminance meter for measuring luminance, that is luminous flux per unit area and unit solid angle, light meter, an instrument used to set photographic exposures. It can be either a lux meter or a luminance meter, and is calibrated in photographic units. Integrating sphere for collecting the total luminous flux of a light source, which can then be measured by a photometer, densitometer for measuring the degree to which a photographic material reflects or transmits light, color, colorimetry, tristimulus colorimeter for quantifying colors and calibrating an imaging workflow, hearing, loudness and phon, headphone, loudspeaker, sound pressure gauge, for measuring unequal loudness contour of a human ear. sound level meter calibrated to an equal loudness contour of the human auditory system behind the human ear. Smell, olfactometer, see also the article about olfaction. Temperature, body temperature or core temperature, medical thermometer, see also infrared thermometer, circulatory system, blood-related parameters are listed in a blood test. Electrocardiograph records the electrical activity of the heart, glucose meter for obtaining the status of blood sugar. Sphygmomanometer, a blood pressure meter used to determine blood pressure in medicine. See also category, blood tests, respiratory system. Spirometer, concentration or partial pressure of carbon dioxide in the respiratory gases. Capnograph, nervous system, electroencephalograph records the electrical activity of the brain, musculoskeletal system, power, work of muscles. Ergometer, metabolic system, body fat meter, medical imaging. Computed tomography, magnetic resonance imaging, medical ultrasonography, radiology, tomograph, device and method for non-destructive analysis of multiple measurements done on a geometric object, for producing 2- or 3-dimensional images, representing the inner structure of that geometric object. See also, category physiological instruments and category, medical testing equipment. Meteorology, see also category, meteorological instrumentation and equipment. Navigation and surveying, see also category, navigational equipment and category, navigation. See also category, surveying instruments. Astronomy, radio antenna, telescope, see also category, astronomical instruments and category, astronomical observatories. Military, some instruments, such as telescopes and sea navigation instruments, have had military applications for many centuries. However, the role of instruments in military affairs rose exponentially with the development of technology via applied science, which began in the mid-19th century and has continued through the present day. Military instruments as a class draw on most of the categories of instrument described throughout this article, such as navigation, astronomy, optics and imaging, and the kinetics of moving objects. Common abstract themes that unite military instruments are seeing into the distance, seeing in the dark, knowing an object's geographic location, and knowing and controlling a moving object's path and destination. Special features of these instruments may include ease of use, speed, reliability and accuracy. Uncategorized, specialized, or generalized application. Actograph measures and records animal activity within an experimental chamber. Checkweigher measures precise weight of items in a conveyor line, rejecting under or overweight objects. Densitometer measures light transmission through processed photographic film or transparent material or light reflection from a reflective material. Force platform measures ground reaction force. Gauge, a highly precise measurement instrument, also usable to calibrate other instruments of the same kind. Often found in conjunction with defining or applying technical standards. Gradiometer, any device that measures spatial variations of a physical quantity. For example, as done in gravity gradiometry. Parking meter measures time a vehicle is parked at a particular spot, usually with a fee. Postage meter measures postage used from a prepaid account. S-meter measures the signal strength processed by a communications receiver. Sensor, hypernym for devices that measure with little interaction, typically used in technical applications. Spectroscope is an important tool used by physicists. SWR meter check the quality of the match between the antenna and the transmission line. Time domain reflectometer locates faults in metallic cables. Universal measuring machine measures geometric locations for inspecting tolerances. Fictional devices, tricorder, a multipurpose scanning device, originating from the science-fictional Star Trek series. Sonic screwdriver, a multifunctional device used occasionally for scanning, originating from the science-fictional Doctor Who series. See also. Category, instrument-making corporations, detectors, history of weights and measures, instrumentation, list of measuring devices for a more comprehensive, alphabetical list of devices and the corresponding list of physical quantities. Metrology, Timeline of temperature and pressure measurement technology, Wikipedia, Wiki Project Physics Work List of central experiments, data loggers measuring devices, metrology, history of measurement, list of measuring devices, list of sensors, notes. Note that the alternate spelling meter is never used when referring to a measuring device. References